is Kaya Swiker, and I'm doing my Peacha Kucha on sterilization methods. Sterilization methods are techniques that we use to ensure surgical and medical instruments are properly sterilized. This is essential for the prevention of cross-contamination, as well as preventing infections while using such instruments. Steam sterilization is the most common and inexpensive method. This sterilizes by steam and pressure in the chamber. The steam will be set to 250 to 270 degrees Fahrenheit. There are two types of steam sterilization, such as gravity displacement and pre-vacuum. Gravity displacement steam sterilization. This is when the air in the chamber is pushed down by gravity and goes through a valve by the pressurized steam. The air is then removed from the chamber. This leaves the pressurized steam to sterilize the instruments and takes about 2 hours. Vacuum, or also known as the dynamic air removal sterilizer. This is a chamber with a built-in vacuum that pulls the air out. This allows the steam to penetrate in a shorter period of time for about 3 to 4 minutes. This operates at 250 degrees Fahrenheit. Ethylene oxide is a gas that sterilizes by penetrating the cell membrane. This will cause the cell to break apart and killing any microorganisms on the instruments. This takes about 2.5 hours. This process is low temperature, which makes it very compatible with many instruments. Hydrogen peroxide is a low-temperature sterilization method. This is commonly used on instruments that are heat-sensitive. This works by the hydrogen peroxide vapor being released into the chamber and contacting the exposed instruments. Vaporized hydrogen peroxide is a low-temperature process. The temps will range from 82 to 104 degrees Fahrenheit. This happens in a deep vacuum process where the vapor falls in the chamber. The oxidizing agents kill the microorganisms, then the vapor is vacuumed out, leaving the products of water and oxygen, making this a very safe process. Chemical sterilization is the process in which instruments are immersed in a sterile solution. Some of the solutions that are used are glutamate and peracetic acid. This is usually used on instruments that are smooth and can be exposed on all surfaces, as well as instruments that are moisture resistant. Peracetic acid is one of the solutions you can use in cold chemical sterilization. This solution is most commonly used in the OR, and some of the instruments that are commonly used with this are cords, cameras, and scopes. Glutamate is another solution that is commonly used in cold chemical sterilization. Items for this solution must soak for 10 hours to be sterilized. This also can be used for endoscopes, cameras, and cords, but is deemed less effective due to its long period of soaking. Orthophthalein is a common alternative to glutamate. The only difference is that this is a high-level disinfectant. This is used in the method of cold chemical sterilization, and this is used commonly on instruments such as endoscopes and cystoscopes. Sterilization is another type of steam sterilization. This can happen in a gravity or pre-vacuum chamber. This is when the instruments will be exposed to a rapid penetration of steam. One of the cons of this method is that it has the potential for infections due to its short period of time of exposure. Radiation is a sterilization method that uses ionizing radiation. This method is quite cost-effective as well as effective in killing microorganisms. This is used for single-use instruments. This also can sterilize prepackaged products such as surgical gloves or syringes. Ultrasonic sterilization. This sterilizes through high-frequency sound waves that are transmitted through liquid. This creates cavitation, which will dislodge any contaminants off the instrument. This may take anywhere from 5 to 30 minutes depending on the instrument that is being cleaned. Sterile filtration. This is the process that gets rid of microorganisms from liquids. They do this by using specialized filters that have very small pores. These filters usually range from 0.1 to 0.5 microns. This is usually used in pharmaceuticals. Dry heat sterilization. This uses high temperatures to kill spores and microorganisms. Dry heat sterilizers reach 338 degrees for 1 hour. This is a good method to use on metal instruments because it will not cause the metal to rust or the instrument to dull. Electron beam irradiation. This uses an accelerator that causes a beam of electrons. This beam is then used on packaged materials such as packaged medical instruments to kill microorganisms. The packaged material goes on through a conveyor belt and then is scanned by the accelerator. Glass bead sterilizers is a small instrument that is used to rapidly sterilize small instruments, usually used in the lab. In the heating chamber, it heats up small glass beads to 572 degrees Fahrenheit. This is hot enough to kill off bacteria, viruses, and microorganisms. Ozone sterilization. This is a gas that is known to be aggressive, oxidating, and an antimicrobial agent. This is produced inside the sterilizer by medical-grade oxygen. This is used on delicate medical instruments, usually such as endoscopes.